Okay, so we're going to go ahead and get started with the second section. This is rational graphing. It says for the following functions, list the transformations, state the domain and range, list the horizontal and vertical asymptotes, and graphs. This is a good just review of what we've been doing for rational functions. Alright, I'm going to start with number 11. So your function is 3 over x minus 2 plus 4. So first I'm going to state the transformation. So this 3 right here means it's going to be a vertical stretch or expansion by 3. This right here is going to mean that it's going to go right 2 because you're in horizontal land and you do the opposite, right? It's kind of like you have parentheses right here. And this is on the outside, it's vertical, so you're going to go up 4. So these right here are your transformations. Every time I do these problems, guys, I like to do a little sketch. I think sketches are good. I think sometimes if we get too just dependent on our calculator, we sometimes forget to think. So I'm going to go ahead and go right 2. So this is my new asymptote. It's kind of like my y-axis shifted. And then I'm going to go up 4. It looks just like this. Here are my asymptotes. Now, you guys remember the parent function, let me change it right here. Parent function 1 over x is in the first and the third quadrant. Now here, we're going to stay in the first and third quadrant. Because it's a vertical stretch by 3, that doesn't do anything to the domain and range. Domain and range only depend on whether it goes up or down or left or right. The stretches and compressions, that just is kind of like having a rubber band, right? You pull it and it stretches, but you're not moving it around. That's what I always tell my kiddos. So I'm just going to do a little sketch, and it's still going to be first and third quadrant, just like that. Alright, so let me go ahead and list the domain. Looking at my graph, the domain is left to right, so I'm going to go negative infinity all the way till I get to my asymptote, and that's at 2. Now it's getting really, really close to 2, but it doesn't actually hit 2, so I'm going to put close parentheses, and there's a break in my asymptote, so that's union. I'm going to start again here at the asymptote. This arrow now is getting really, really close to the asymptote, so that's 2 again, and then you keep going to the right all the way to positive infinity. That's interval notation. If you wanted to do it in set builder notation, it would just be all real numbers except your x cannot be 2. Alright, so let's now talk about our range. Our range is bottom to top. So my range is going to be negative infinity all the way to this asymptote right here, our horizontal asymptote, and that's at 4. So it gets really, really close to 4, but it actually doesn't hit 4, so that's a parentheses. Union again means or. And then there's this break, so that's your union. And then you start again at this asymptote, so it's going to be 4 all the way up to positive infinity. If I want this guy in set builder notation, it's going to be the same thing, all real numbers, except now it's y's range, so your y cannot be 4. So there is your domain and range. Alright, so now we got to list our vertical and horizontal asymptotes. Here it's kind of tricky. You have to be careful, guys. For our vertical asymptote, that's this guy here, right? He's vertical. It's what he crosses. So this is my x-axis, and this is my y-axis, right? So this line crosses the x-axis. So that's how I know this is going to be an x equals 2, right? It crosses at x equals 2. So this is my vertical asymptote, or my VA. Here, this asymptote, remember, it's our horizontal asymptote, so it's our HA, and it's crossing at 4. So it's crossing the y-axis at 4, right? It's where it crosses, and that's the equation there. Alright, so I think that's everything that we have. We have listing our transformations, domain and range. We draw a sketch. We list the vertical and horizontal asymptotes. Good. And so for the picture, guys, if you want an exact picture, like I said, you can go to your graph, y equals, plug it in, 3 divided by. Make sure you put the bottom in parentheses, very important. Close the parentheses, plus 4 on the end. And if you hit graph, there it is. Let me do my normal graph. So you can see it lines up just with our sketch and what we drew. Good. Alright, so I'm going to go ahead and do number 12. So this one, you have f of x equals negative. Now this negative is kind of sticking on the outside. I always tell my kids that's either on the outside or on the front, the same thing. Now I'm going to list my transformations. So this right here, this 2, means you have a vertical stretch or expansion by 2. This negative, since it's on the outside and or on the top, it's going to flip over the x-axis. Or you can say this is a vertical flip. Okay? And then I have here, right, this is in parentheses, this is going to go left 5, and then right here is going to be down 1. So these are my transformations. Let me scooch this over so y'all can see a little bit better. Okay, so the next thing I'm going to do is draw a sketch. Always draw a sketch. So I'm going to go left 5. So 1, 2, 3, 4, 5. So this is my new asymptote. And I'm going to go down 1. So here's my new asymptote. There it is. Now, vertical stretch, right? It's not gonna change the domain and range. So I'm just drawing a sketch. Vertical flip. So it's gonna flip over the x-axis. But remember, not this x-axis. It's gonna be over this guy. This is kind of like our new x-axis. So remember, our parent function 1 over x is the first and the third quadrant. So if these guys do a vertical flip over the x-axis, it's going to be the first quadrant and the second quadrant and the fourth quadrant. So it's going to look like this. Just like that. See how it flips? Alright, so let's go ahead and write our domain and range. Our domain from this guy is going to be negative infinity all the way to your asymptote, which is at negative 5, union, and then I'm going to go again, start at negative 5 down here with this arrow, so negative 5 to positive infinity. If I want to write this in set builder notation, it's going to be all real numbers except that x cannot be negative 5. Alright, so let's talk about our range. Our range is our y value, so it's bottom to top. So bottom, you go to negative infinity, all the way up, and then you stop here at your asymptote. That's at negative 1. It doesn't hit the asymptote, remember, so that's why you put a parentheses. You have a break, so union, and then you start again, negative 1 to positive infinity. If I want to do this set builder notation, all real numbers, sorry, not x, this is y because it's range, y cannot be negative 1. There you go. So we have our domain and range. And now I just need to list my equations of my vertical and horizontal asymptote. So this guy right here is your horizontal asymptote, your ha. And remember, it's what he crosses. You see how he's crossing? This is your x-axis and this is your y-axis. He's crossing your y-axis at negative 1. That's that. And then this one right here is crossing, this is your vertical asymptote. He's crossing your vertical asymptote at 5. So I'm going to write, it's crossing the x-axis, so x equals -5. There it is. Alright, so this is what I have for rational graphing. If you guys look at the 11b and 12b, this is kind of cool. So it's saying for 11, going back to 11, right, this is my equation, b. It says write a new equation if the graph now had a domain where x could not equal 3 and the range could not equal 1. So let me draw a little sketch for that. 11, this is 11b. It says x cannot equal 3. So this is your xy. If x cannot equal 3, I'm going to draw an asymptote at 3. And the range is your y, and that can't equal 1. So here's my y1. And there's your asymptote. So what did this do? This went right 3 and up 1. So they want us to write a new equation. So my equation is just going to change. Keep the vertical stretch the same, but instead of going right 2, this one's going to go right 3. So it's x minus 3, and instead of going up 4, it's now just going to go up 1. So there's the answer to that. And now let's look at 12b. Flip my paper around. So here's my equation. So it says, write a new equation if the now had a vertical asymptote at x equals 7 and a horizontal asymptote as y equals 0. Alright, so I'm going to draw a little quick sketch. X equals 7 and y equals 0. This is your x-axis, this is your y-axis. Y equals 0, so that's your here. So the graph didn't shift up or down, right? So it just stayed there. So this is going to go to 0. And then we're going to go right 7, right? So then this is going to be opposite because it's horizontal. So it's going to be x equals, or x minus 7. So my equation will look like this. -2, right, goes right 7, so x minus 7. And then it's plus 0, so that's it. That's your new equation. Alright, so this was the second part of rational graphing.